For this lesson, we're going to graph the equation using its format, and it is in slope-intercept format. The other format is standard form, but slope-intercept is the one we're going to take a look at today. As you can see, I'm using the same exact equation that I used in the last video lesson, and I'm going to go so far as to take the points off this line. I'm going to leave the same line there, the same solution to this equation, just to prove that we end up with the same answer, either way we go about graphing it. This one relies on us knowing the meaning of slope-intercept form, which is y equals mx plus b. M represents the slope of the line, that is the steepness, if you will, which is often defined as rise over run, and that's how we're going to look at it today. Rise over run. It's also sometimes referred to as rate of change. Forgive the handwriting, I'm using this tablet and it's difficult. It doesn't have a touch screen. Well, anyhow, it's a tablet, it's difficult. It's not as easy as you would think. Anyhow, the B represents what we call the y-intercept. Y-intercept. Let's just pretend that says intercept. So we have the two parts we need. Now the y and the x, we're not going to do anything with the y and the x because those values represent solutions to the equation. If we wanted to work with the y and the x values, which again representing a solution, an ordered pair that would be on this line that make this equation true, well, then you should be watching the last lesson where we picked numbers for x, got the y value, and then graphed the ordered pair. We aren't really going to need the x and y this time, so we're just going to concentrate on the slope itself and this y-intercept. To graph using slope-intercept form, you don't have to do any calculating or anything like that. We're going to take a look at the y-intercept first. So I'm going to take this y-intercept here, which is 3, and I'm going to put a little point on the y-axis. The y-intercept is where the line will intercept the y-axis. So that's what this is here. So that's whatever is in place here for the b value. That's what's going to be graphed first on the line. So you can see already we have a point that is on this line. So it is a solution, this ordered pair 0, 3. So first graph that. That's nice and easy, 3. The next thing to graph is the slope, which is, we're going to consider it as, we're going to think about it in terms of rise over run. That's our slope, okay? Slope is the variable m. In this case, it's 2. Now, most of you will remember that if you're going to work with a whole number, but you want to think about it in terms of a fraction, well, we'll think about this as 2 over 1, okay? And again, if we're thinking back here about rise over run, well, 2 will be the rise, and over the run, which is 1. What does that mean? Well, we go back to where we put our y-intercept point right here on 3 on the y-axis. That was easy. Now what we're going to do is rise 2 units and do a run of 1. So rising 2, we'll go up here, up 1, 2, and then a run of 1 and put a point. I could repeat this, I'll go off the grid, but rise 2, 1, 2, and run of 1, so I go over 1 point, or 1 unit rather, and put a point. There we go. I could work in reverse too. I could do, like, instead of going up or rise, I could go down. Instead of run to the right, I could go left. So I could go down 2, 1, 2, and a run to the left, 1 place. Down 2, 1, 2, and a run to the left, 1 place. I can do that as much as I want to, and it would just make the line that much more exact. But you can see here the slope is always almost like a stair stepping. Okay, Here's the rise, rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, and it just repeats like that. And we have what we call, like I said before down here, rate of change. The rate of change is 2 over 1. It is the slope for every unit, or up, in this case every 2 units up, you have a 1 unit run. And that helps form our line. You can see that we're ending up with many multiple points here that are all solutions to this equation, and they are all points on this line, the line representing all possible solutions to this equation. So that's one way to graph an equation without doing any calculations. So let's look at one more. Let's get a clean page here. It's getting kind of cluttered. We'll get on the coordinate plane, and we'll get an equation. Let's take a look at, let's do something like y equals 2/3 x plus 1. So the first thing to do is to look for your y-intercept, which is right there. Okay, remember, this is this equation is in slope-intercept form. We can see it models slope-intercept form. And the b value, the y-intercept value, is 1. So I'm going to go over here on the y-axis. This is the y-intercept. I'm going to put a point at 1. Easy. Now, the slope right here is 2/3. And again, that's rise over run. So I'm going to rise 2 and do a run of 3. So rise 2, 1, 2. Oh, and start right here on the y-intercept. Rise 2, 1, 2, and a run of 3. 1, 2, 3. Put a point. Rise 2, 1, 2, and run of 3. 1, 2, 3, and put a point. And that's our line. Let's graph that across like that. Make sure we put arrows on there. And we got 1. And we're done. That will be the graph of the line. So it's nice and easy. If you know what the y-intercept means and what it is, it's where the line is intercepting the y-axis, y-intercept. So plot that. And then once you have that, build the next point or several points using the slope, which is defined for us as rise over run. In this case, rising 2 and a run of 3. One last thing, if you ever have a negative number, you need to take that negative and place it with either the numerator or denominator. You're either going to, if you have it up with what would be the rise, in this case with a negative, you'll go down 2. If you want to put the negative with the denominator, which is the run, then you'll head to the left instead of the right. So if this equation had been y equals negative 2/3 x plus 1, the y-intercept would still be right here at 1, but this would be going down 2, all right, instead of rising. I could go down 2, 1, 2, and then a run of 3. It's going to go to the right, 1, 2, 3, put a point, down 2, 1, 2, and then a run of 3, 1, 2, 3, right there. You can see our line is going to look a bit different. This line is falling rather than the other line, which appears to be rising. So anytime you have a negative slope, you will find that you have a line graph that's falling versus a positive slope where the line appears to be rising. And that's graphing equations using the slope-intercept form.